Hi everyone, welcome back to this channel. This quick video, I'm going to show you two things regarding the Proxim software before we jump into all the software that will work with this Proxim hardware. So these are the two things that normally we overlook, and this is kind of important informations to know. I hope that this will be a reference for you. So the first thing I want to show you is that you can actually replay a certain segment of your emulations. Like for example, I want to start from 300 seconds to 330 seconds because I just want to focus on these portions where the event happened in the way that I want, and somehow my device under test responds poorly. So I just capture from 300 seconds to 336 seconds. So how do we do it? First of all, you have to pause it. And then we go to this continuous setup, single run. So we say from 300 to 340. 300 to 340. So you can set it to run single, which is just this portion, or you can stop and rerun the segment repeatedly. The only problem with this one is that it needs some time to re-engage the conditions, and I can show it to you right now. So once you set that up, so first of all, the software will try to find where it's supposed to be and put this portion into the memory, and then when we click play, it will just play back within this portion of 40 seconds. So I'm going to speed it up. So this way you're going to see some delay when it goes back to the front again. See that? So remember the kind of messy part beginning, so that's where the memory tries to relock it. So you can actually see here the system lock, and again I will just jump straight to that, see whether it can stop that. So you're going to see it pause and then emulating again. Pause and emulate. So this is one of the things that you have to be aware if you play a certain part of that emulations. So the second thing I want to show you is this. So let's go back to the setup view. This is where you can set the path loss and other necessary parameter to make sure that it doesn't overload on the Proxim as an input and also drive too hard on the output side. So I have this analyzer at the output of the Proxim. So I'm placing the Firefox on the right side of the screen so that you can see the power level change when I change any other parameter over here. So we are using MANET 1 to 2, which is port 2 to port 4 on the Proxim, and port 4 connected to the analyzer. Port 2 is connected to another Firefox, which is transmitting at 0 dBm and switch between 400 to 500 megahertz. So with that in mind, let's say we change the in loss, means that we try to emulate the real life where the transmitter to the receiver, we have a RF loss. For example, over the air, we have antenna to antennas at a certain distance. This is a loss value. When you put in positive, it's the loss. When you put in negative, it becomes a gain. So negative, negative. So as you can see here, it's about minus 2.9, so we know our loss of the cable probably around 3 dB. So when I put it there at the receiver of the Proxim, it measures about minus 0.1 dBm, which is close to 0 dBm. So when you put a positive number here, it becomes a loss. When you put a negative here, it indicates to the Proxim that that is an amplifier. And if I really have a 3 dB amplifier plus the 0 dBm, I get a 3 dB minus 3. By the time I get to Proxim, it becomes 0. So it's just a bit of arithmetic. So let's go back to that, level down to 0 dBm. Let's say I have a 10 dB loss. Currently, my Firefox is connected to Proxim directly using a cable, and the value is a bit different, so it compensates that. That's why the reading is a bit different. So it's assumed that the transmitter is transmitting at about 9 dBm. And minus of the 10 dB loss, it should be equivalent to 0 dB at the receiver of the Proxim. So let's go back to 3 dB, which is what we want, assuming that that's my physical cable loss. So input level is another one that you can change around. It's actually depending on this input crest factor, which depending on this type of burst, level, threshold, you can call it that way. So by changing the input level, you essentially moving the window of the dynamic range of the Proxim at the input port towards higher power or lower power. So these are expectations. So if I change that to, let's say, minus 25, you can see that the power level here will be higher and this cutoff warning comes out because the power level is way too high. So we have to revert back to 15 so that it can go back to a reasonable level. So this is one of the things when you see a warning or an error, try not to ignore it, change the parameter accordingly. The reason why we have it here is that it will protect your investment, as in Proxim right now in this case, so that you won't overdrive the ADC and break it. The same for the output here. You can change the output level. So how do you see the limit? You can hover your mouse over and it will tell you the range. So the output level for this one is minus 50, minus 45. So we try to put it somewhere below that. So let's say we change it to minus 80. So what will happen is that it expects the power to be somewhere around that region, and they will attenuate and change it accordingly so that when the output out from the Proxim will be about the range. Let's change it to minus 63 again. So that's what we want to see. And output loss is another compensations, let's say from the Proxim to your UE, assuming that you're over the air. Again, if you put in positive number, it's a loss, the attenuations. So you put in 10, you assume that there's a 10 dB loss, and then they try to compensate it. So by the time you reach your UE, will be minus 45. So if you put a negative here, it becomes a gain. So assuming that there is an amplifier between Proxim and your device under test, the power level that's output from Proxim will be lower by 10, because it assumed that there is an amplifier that have a gain of 10. So from minus 54 plus 10, you get a minus 44. So I hope this helped, because a lot of time without changing all these things, your device under test at the other end might receive a power that is too high for it to operate normally, or saturate the amplifier or the front end of your device under test. Thus cause disconnections, amplifier overload. These are the things that you can actually change so that your device will still work at the linear region and will run your test eventually. This is again adjustment, assuming that like a satellite bandpipe, you have amplifier, you can actually boost up the signal over here, and this is gain. So if you put it positive, it becomes a gain. So it actually push up your signal. So if it's negative, it would be attenuations. So look at the name of it. If it's loss, then it's the reverse. If it's gain, then if it's positive, it's gain, negative be loss. So it'll be confusing, but you get used to it. So I hope this helped. Thanks for watching.